Today in this video we'll talk about something called Kerchief Voltage law. We need it in series circuits. Also we need it in some circuits that containing smaller series circuits sometimes. So it's very important to lecture like we used to say. And let's go in. So this is circuits with V1 or battery 1, 240 V. R1 is 30 ohm, R2 is 60 ohm, R3 with a 20 ohm, and V2 is with the 20 volt. If you see this one and this one, they are opposite directions. So this one will go circuit clockwise, and this one will go counterclockwise. So what's KV? KV is used in series like we mentioned. KV should work as clockwise, and source should be in positive, not exactly positive but always positive. We'll see what that means. And resistors or anything that consume electricity should be in minus. So source minus resistors will equal 0. For example, the circuits, we got a V1, and if you go this direction like clockwise, V1 is this, R1 or VR1 is this one, so in minus because resistance, R2 which is VR2 in minus, VR3 in minus because both they are resistors. V2 is in minus because it's opposite the direction of the main or the bigger voltage that we mentioned before, V1. So the equation would be this one equals 0. Now we got V1 is 240, V2 is 20, we'll put in minus, and VR1, VR2, VR3, all they have a same currents, I1. So I1, like we mentioned before in ohm voltage law, I multiplied by R equal V. So for VR1 it will be I R1. Same for this one, except like the R2 is different or the R is different, but they are sharing the I, and this one is the same. R3 is different and I1 is common. I is common because it's series. All equal zeros. Now we plug all the numbers. 220 because this one become like this one, minus I, and I is common here, so minus I is out, and we got R1, R2, R3 addition equals zeros. Now we'll take all these parts to a different side, so it will be this one, and now we add R1, R2, R3. We've got 110. I is still unknown, so now we will divide 220 by 10. So I the current is going through the series, it will be 2 ampere. Okay, how we can use this one to understand more KV? Sometimes we'll give you VR1, VR2, and they will not give you VR3. So we will use all this number, VR1, VR2, we'll plug it here, and we got V1, V2, still VR3 unknown, so we will apply this kind of equation, and we can find VR3. And there is something we should mention before we close these videos. VR1, VR2, VR3, it will equal 40 voltage because we use this one. 2 multiplied by 30, it will be 60. 2 multiplied by 60, it will be 120. 2 multiplied by 20, it will be 40. When we add all this, 60, 120, 40, we'll got 2 volt to 20, 200 volt and 20. So we can check it in different way. So that's the way we can use the KVL in series circuits. Have a good night.